Probability notes. First, let's look at some definitions. Likelihood is defined as how possible it is for something to happen. Probability is defined as a number between 0 and 1 that represents the likelihood an event will occur or happen. So remember, you're only looking for numbers that could be fractions, decimals, anything between 0 and 1. So if you look at this line that we have here, all the way on the left, it has impossible written under it. In the middle, it has equally likely as unlikely, and then certain is on the right. So if you had a number that was 0, that something absolutely could not happen, it would be impossible, that would be correlated to the number 0. And then 1 would mean that it was absolutely certain, it would always happen. In the middle, you would have something that could be like the fraction 1/2 or the decimal 0.5, because it's exactly halfway between 0 and 1. So if you are going towards the left, it would be unlikely. And if you were going towards the right, it would be likely that something would happen. Theoretical probabilities define as the number of favorable outcomes over the total number of possible outcomes. So if you look at this equation here, you will see a capital P. P stands for probability. And then in parentheses, it's what you were looking for. So in this case, of an event happening. On the top, or the numerator of the fraction, you have the number of favorable outcomes, or the number of actual things that can happen. On the bottom, the denominator, you have the total number of possible outcomes. So what completely could happen. And remember, this is what you think will happen. This is just when you're crunching numbers and trying to figure out what the possibility is. This is not if you actually perform it. That's experimental probability, which we will do at another time. Let's look at some examples. The directions are to write the probability as a fraction, then convert to a decimal, and finally state the likelihood. Is it likely or unlikely or equally likely as unlikely? So when you look at the spinner that's on the right-hand side, first, to put it in a fraction, you could draw your fraction bar, and on the bottom of the fraction is going to be the total number of possibilities. So when you look, we have a 1, we have a 2, a 3, a 4, a 5, and a 6. That means there are 6 total possibilities, and that would go on the bottom. Then we want to know the probability of spinning a 1. That's what the P and the 1 in the parentheses means. So the probability of spinning a 1. So you look at how many 1s there are there, so how many times it could possibly land on a 1, and we only have this 1 here, so the probability of spinning a 1 is 1/6. Then your next direction is to convert it to a decimal. So when you put it in the calculator, 1 divided by 6 is 0.1666666, and it goes on forever. So what we do is we put that bar on top of the 6 to show that it's a repeating decimal, that the 6 goes on forever. When you look at our number line, remember that 0 was totally not likely, it's impossible. Then we have the 1, which means that it's always going to happen. Absolutely, it is possible. When you look at where 0.16 would be on there, that would be really low. So that means that how likely it would be unlikely. Now let's look at the likelihood of spinning a number that is greater than 2. So again, when you draw your fraction, you look at how many possible choices you have. And here again, we have 6, so that goes on the bottom of the fraction. Now we want a number that is greater than 2, and it does not say greater than or equal to, so that means it can't be 1 and it can't be 2. But 3 is greater, 4 is greater, 5 is greater, and 6 is greater. That means we have 4 possible choices, so that goes on the numerator. Now we can reduce this fraction. 4, 6, each number could be divided by 2, and it would be 2/3. Then we need to change it to a decimal. When you type in 2 divided by 3, you will get 0.66666, and that goes on forever. So again, we're going to show the bar on top of the 6 to show it's a repeating decimal. When you look at your number line, remembering that 0 is all the way on the left and 1 is all the way on the right, 0.6 is bigger than half, or 0.5, so that means that it's going to be actually likely. Now let's look at the possibility or probability of spinning a 3 or a 4. Again, start with your fraction. We have 6 possible choices, so 6 goes on the bottom. When we look at the 3 and 4, we have 1 3 and 1 4. Now remember, if the pie slice was bigger for the 3 or the 4, that would count as more than 1. Or if there were more than 1 3 or more than 1 4, you have to make sure you count all of them. But in this case, we only have 1 3 and 1 4, so the total is 2. So it would be 2 6, and we can simplify that fraction by dividing by 2 by the numerator and the denominator, and that gives us 1/3. When you put that in the calculator, 1 divided by 3 is 0.33333. That goes on forever, so we show the bar above the 3 to show that it's a repeating decimal. When you look at your number line and look at the 0 and the 1, 0.3 is definitely less than 0.5, so it's going to be unlikely that this would happen. Now let's look at the probability of not getting a 2. Again, we start with our fraction. We have 6 possible choices. Remember that there would be less than 6 choices if any of those numbers were repeated. But in this case, each one's there one time, so there are 6 choices. Now, we want to see any numbers that are not 2. 1's not 2, 3, 4, 5, and 6. When you add them up, that is 5 total choices that are not 2. So that means that we have 5/6 of a chance of scoring this probability. When you make it into a decimal, 5 divided by 6 is 0.833333, and that repeats. So we'll put the bar above the 3 to show the repeating decimal. When you look at your number line and 0 and 1, and remembering that 0.5 is right in the middle, 0.83 is greater than that, so that means that this event is likely. In the next set of examples, you're going to put the letters holidays in a bag. So the HOLIDAY and S in a bag, and then pull from the bag. And we want to see what is the probability of pulling out a vowel. Now remember, we're only looking for the 5 real vowels. We're not counting the Y. So first, when you start with your fraction, start with how many total letters there are. You have 1, 2, 3, 4, 5, 6, 7, 8 letters in the word holidays. Then for a vowel, we have an O, we have an I, and we have an A. There are only 3 vowels, so the 3 would go on the top. 3/8 then you need to convert to a decimal, and that's going to equal 0.375. When you look at your scale of 0 to 1, remembering that 0.5 is in the middle, 0.375 is less than that, so that means that this is unlikely. Now let's look at the probability of not pulling an A out of the bag of letters. Remember that we have 8 total letters in holidays, so that goes on the bottom of the fraction. There is 1 A, which means that there are 7 that are not an A, so 7 goes on the top. When you convert this to a fraction, it is 0.875. Looking at your number line of 0, 1, and then 0.5 in the middle, you'll notice that 0.875 is bigger than 0.5, which means that this event is likely. Now for the probability of pulling out a W. Remember, you start with the fraction. Total number of letters was 8. In here, when you count up the W's, you see there is absolutely none. So there's 0 on the top of the fraction. When you convert this into a decimal, it actually is 0. So when you look at your number line, remembering that 0 is on the left and 1 is on the right, 0 is not only unlikely, it is absolutely impossible. You will never be able to pull out a W out of that bag.